Low, okay. All right, take two, marker. Let's try this again. Take two. Marker. Ladies and gentlemen, good morning. It is March 11th, 5:59 a.m. on the beautiful East Coast of the United States. I am Tony, and this is Red Cyber Dragon, and it is 2 degrees centigrade outside. Today, we're going to be doing some game dev. I would like to figure out how to save stuff. Save player state and such, how many coins they've earned and things like that. So we're going to try to figure that out this morning. So please come along on this journey with me, and let's make a game together. Just a tad, though. All right. So, let's My limiter not on? Hello? Hi! Now, why is it peaking like that? Hold up. Oh. Because the gain is so high. Oh, we don't want any... Hello? Hello, hello, hello. Hello, 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 hello. Hello, everybody. Hello, everybody. What's up? Hey, everybody. How's it going? It's Tony. Hey, everybody. What's going on? It's Tony. Everybody doing okay? Hope everybody's doing great. Sound check, sound check, sound check. I guess that's fine. It sound okay? Okay. Sorry, I had to fix YouTube. YouTube. Oh, YouTube. Why? I don't know, my microphone seems different today. I don't know why. The gain shouldn't be turned up at all. But also it keeps peaking. Anyway, I don't want to keep messing around with this. Let's Let's do stuff. This music feels really sad. There. Okay, let's talk about a few things that we've done in the game in the last week. So, remember before we had fireballs? I did something yesterday. I'm not even sure if I want to keep it, but I'll show you it. So, if you hit F now, the fireball has textures. Sorry, not textures, particles. Instead of being an animation, it's got a particle element to it. I'll show you again. If we look at it, watch fire it. It doesn't work quite right yet, but you can see that it's got particles coming out the back instead of just being that animated sprite. I'm not even sure if it looks better or not. It may be better just to go with the animated one, but I wanted to try it so that I could kind of learn how particles work, at least a little bit. But you can see it here. This is what it looks like. These are CPU particles. You see we got colors mixed in there, and you can mess with like these settings over here. Like if we extend the lifetime, it'll go farther, right? That's way too long. Or see, we do it for like 5 seconds. It's really long. It's like a comet. We do 1 second. It's like that. What else? The shape that the emission is. So like, it's coming from like a circle, like they're being emitted from a circle, versus like a square surface. Okay. Oh, a sphere surface. Rectangle. See, you can see a difference there for sure. Sphere. And then you can increase or decrease the size. We did sphere. That makes a lot of sense. Make it quite large though. The one thing I'm gonna have to figure out though is how to like create like a CPU particle animation for like the explosion. I don't know how I'd do that. Would it be a separate particle that only comes when like there's a collision or something? I don't know. I'm gonna have to learn more about how particles work for that. But I still think it's pretty cool to make something like this. Like, I didn't need an asset or anything, and I got a fireball here. That's pretty cool. Hue variation. Minimum. That means it'll change. I don't know. It'll have different colors. More often. Animation. Again, I don't know what any of this stuff does. You kind of just have to look at it and mess with it until what you've got looks cool, you know? Speed minimum. offset minimum, offset curve, visibility, texture, material, process. Anyways, it's kind of interesting. Oh, it's got things like speed scale. Yeah, so you can like make it just do exactly what it's doing but faster. In fact, I actually think that's not a bad idea. Anyways, so I'll mess more with that later. I put on... So what I want to do is figure out what do we need to save and where's the best place to save it. That's sort of the mission for the stream this morning. Oh, one more thing I want to show you guys. I told you I was going to put this on mobile also. So we took a step towards that, and I got a touch control here. Watch this. This is cool. Ah! Oh! Anyways. Yeah, so that's going to be for mobile. And this was just a plugin I found on the asset store. It's called like Virtual Joystick. Really cool. And then the PNG for it is just something I bought off of the... Or it was part of the assets that I bought for the game. So it matches the art style and everything already. I think it's probably a little too big. Also, I don't even know if the entire game is the right aspect ratio. Probably not, because I don't think... I think this is too... This isn't wide enough for a phone. But we'll get to that later. I'm gonna do mobile development later. Like, I really am trying to get the basics done before we start talking about mobile. Because that's gonna cost more money too, because we have to get a developer account and everything for the app stores. And, well, with Android, we don't really have to go on the App Store necessarily, but with Apple, we do. And you have to do all kinds of things through them. But we're going to do it because if this, you know, that's where most people who play games like this are. They're on mobile, honestly. Like, that's just it. And you know, we're not expecting to make really any money with this one, but we want to reach as many people as possible, you know, so that, you know, we build our support base, and then when we release something new or the next version of this, people are excited. Oh, that doesn't change directions. Damn. I have to fix that. It does look kind of cool, though. You gotta admit that. That's pretty cool. Plus, I can make that any shape I want. I could even make different kinds of them. And at different times, or whatever, he could blow different kinds of fire. So yeah, I think I like this particle effect for sure. I like these particles, yeah. Okay. So let's look up some videos on save data. Okay. Okay. Godot makes saves so easy. Okay, well, I don't know if I believe you, but sure.
One thing you need in every game is to save the player's progression. Fortunately for you, the GODOT Game Engine makes this really easy. First, there's the wrong way to do it. There's a popular data format named JSON that about every programming language supports, including Godot's GDScript. It's widely used to exchange data on the web or between programs, and it works for that purpose. It can seem like a nice way to save the player data, but Godot has a much faster option, the resource format. It's the format that Godot uses to save all your project data: animations, scenes, materials, particles, and much more. For player saves, it only has advantages. It supports all Godot value types like vectors out of the box, it requires way less code, offers excellent performance, and it's super flexible. It's both robust and convenient. Here's all the code I need to save and load the character stats, the inventory, their map, and their position on the map.
Stop. Okay. So resources slash save game GD, character GD, export to level, experience, strength. Extends resource, array, resource. Okay, so that's just the stuff you're saving. Item, class name, save game, resource, save game path, R, inventory. Okay, okay, okay. Extends resource. Resource. Does it have to be resource? I think that's what it is, right?
It's only a couple of lines. To save your game with a resource, you first create a script that extends resource. You export a variable for each thing that you want to save. That can be anything like numbers, strings, dictionaries, and most importantly, other resources. Godot will pack all the data in one file automatically. You can directly load all the other resources you want to save from your save game resource, like the character stats, the player's inventory, and so on. Godot will load each unique resource only once, even if you try to load it in different places. To save, you call the resourceSaver.save function. To load the save game, you just call load. And that's what you need to get your save system started. Godot does the heavy lifting for you. Now, of course, there's more to say about saving player data with resources. In the next video, I'll show you how this save game example works in detail, so subscribe and turn on the notification bell to not miss it. If you want to become a game developer with Godot, check out our course, Learn to Code from Zero. It's the most comprehensive course out there for beginners. And if you're an experienced developer, you will surely like our ultimate cookbook, Godot Node Essentials. You'll find the links in the description.
I might have to
Be
take a
great,
look at that.
have fun, and I'll see you in the next one. One thing you need in every game is to save the player's progression. In this video, I'll show you what I consider Godot's most powerful built-in tool to save and load the game: resources. As we saw in the previous video, resources make saves easy and very flexible. Performance is good, and it can save you more and more code as your game gets bigger. I've prepared a free and open source demo that shows how to save and load the player's position, character stats, and an inventory. I'll first give you a brief overview of the project. You'll then see how the inventory menu and the player use resources to store items and stats. We'll then see how the save game resource uses those to save game data. Finally, we'll look at the main game script that dispatches the loaded inventory and stats. This video is sponsored by our in-depth Godot courses.
Ethical Reacts. Ethical Reacts. Ethical Reacts.
Find them in the description below.
Go to GD Quest.
You can download
I'm
the demo
subscribing.
for this video on GitHub. You'll find a link in the description below. When you open it, you'll land on a scene where you'll have a character, a level, and 3 pieces of UI. 1 to edit the inventory, 1 to edit the character's stats, and 1 to save and load the game in the bottom left. So if I run the scene now, you can see I already have some saved data, but so I can change the character's run speed, I can change the stats, which are just numbers really, and then I can click the buttons.
There's something about the way this looks that just makes me so happy. Like, I have no idea what it is. Do you know what that is? You know when just something looks so good on a computer screen that you're just like, cool. I'm in a good mood now. You know, I have no idea if that's a normal thing or not, but this looks so cool. I want to go and buy their course right now. Like,
in the inventory to add and remove items. Now, the interesting thing is when I press load, everything gets reloaded, and we're going to see how. To start with, let's look at the character. So I'm going to open the player character scene,
right?
And then I'm going to click the script icon to open the player character's script. This is your typical top-down movement script. For the most part, the important bit regarding save games is this variable. Stats is a variable that uses a type named character. This is another script from the project, so you can control-click to open it. And there you will find a bunch of exported variables and a script that extends resources.
Okay.
Allow.
So he's not using resource as the player character. He's not making the player itself a resource. He's just got a player resource, and it's called character. It's a little confusing. I would maybe call it character resource, just so that you understand what it is and that it's not the player. Just an opinion, or just like character data or something like that. I don't know, but all right, this is making sense. So let's continue.
Godot to save and load these properties. And so we have the character's name, movement speed, this is what controls the speed of the character, and the stats you saw in the running game. If I go back to the player character script, let's see how these stats get used. I'll go down to physics process, and when I calculate the character's target speed, basically, I use stats.runSpeed instead of a hard-coded variable that would be in this script. By using
okay, so desired velocity equals stats.runSpeed, and stats where did stats come from? Okay, stats is character set stats. Where does set stats come from?
I'll go down to physics process, and when I calculate the character's target speed, basically, I use stats.runSpeed instead of a hard-coded variable that would be in this script. By using resources like these, instead of variables that are directly in your script, you make them very easy to save. All right, let's look at the inventory now. So I'm going to go back to the game scene and open UI inventory, and then I open its script. There again, you'll see a variable named inventory, and it takes an inventory resource, a resource that's pretty simple. It just has a dictionary holding the game's items, but it also has functions to add items, get an item's amount, and remove an item. And we use that to manage the player's inventory. All the data is in this resource. The UI inventory is only going to display the content of this resource. As you can see here, right, you have a function named update item display, and whenever we change the inventory, we call that function. So let's look at the code flow. We have a variable called inventory. When we assign it an inventory, it's going to call set inventory. Set inventory is down here, and it takes an inventory resource. When we pass a new inventory resource, we're going to connect to the resource.change signal. Every resource has it. And whenever it's emitted, we call update item display. So every time we add or remove an item, we emit that signal, and it calls update item display. And this function is going to redraw the menu from scratch. It removes all the displayed items and adds them again. So that's how it works. And we added a couple of functions in there just to be able to add or remove item from the menu and the inventory resource. And with that, we can look at how the save system works. I'm back to my main game scene, and I'm going to open the save game resource script. So in the file system doc, I expand resources, where you'll find the character and inventory resources, and also the save game. I double click it to open it, and there you can see already at the top that, well, this is a resource, and it exports a couple of variables. This is what will get saved in the save file. It saves one character, one inventory, the map's name, it's not used, but it's there, and the global position of the character. This is how we can save and load all this data of the character. Now, the cool thing about that is that you just need to give it the character resource and the inventory resource, and you also give them to the player character and the inventory interface, respectively.
Right.
And when you change something in the interface, it automatically updates here in the save game as well, because resources get shared in memory, right? And so then, to save your game, all you have to do is call this resourcesaver.save, and you give it a path, right? And the resource to save, of course. So I've written that code inside of the save game resource, but you could call resourcesaver.save, save game path, and pass the resource from some other place in your game.
Right.
Very important regarding your save game path. It needs to start with user://. When you ship your game to your players, you cannot use the path that starts with res, because
that's
this
resources
is for your project files, and these are typically in a package, in a zip file if you want, when you release the game. So they are often not accessible to write. That's why Godot provides another path called user, which allows you to save user data, to import player mods, and those kinds of things. All right. Then there's this thing that I want to talk about. There is currently a bug in Godot, or a limitation of resources in Godot 3, which makes it so normally you could just do this called resourceloader.load, the save game path. You pass an empty string. This is for the kind of resource you want to load, but you can let Godot detect this.
Okay, so he is using Godot 3.
One thing you need in every
Hello everyone, in this tutorial, I'll be showing you how to make a saving and loading system in Godot 4. To get started, you need to create a custom directory. So go to Project, Project Settings, type in Custom dir. In the config, you could set use custom directory and type in any name you want. So I'll do save system tutorial. And if we close this, run it once, and you press Windows R, go to your app data. As you can see here, all of your data will be stored in this folder, and you'll be able to access it at any time. All right, now let's create a new script, or you can add this to an existing script. I will delete these two for now. I'll create a function called save. This will create a temporary variable for your data. So it will be a dictionary. So we'll do a variable save.
Yeah, I think I know where he's going with this.
We'll get a new dictionary. And at the end of this, we will return our save dictionary. In here, you can add all of the data you want to store, such as a score, which will get your score variable. For now, I'll just set it at a random number. So let's do 1740 or whatever. And to create more, add a comma. Let's do username. You can get this from a variable, like global variable or anywhere else, but I'll just put in a string format, gwiz.
So do they not do resources anymore? Yeah. Resource. You just look at it. I just want to look. Okay. Honestly, the doing it with resources seems way easier than.
And you can do other stuff, like you can get the player's position, you can store that in, position. Go store position as.
We'll look at this real quick and then figure out what we need to do.
Vector 3, let's go 0, 0, 0. And essentially this will be what you're storing. All right, next let's actually call the save function. So let's do a function save game. Here, we will create a variable called save game. We will set this to file access dot open. And here you can actually create the name of your save file. So you need to use user/us, but after this you can name it whatever you would like. So I'll do save game, and it needs to be .save. And we will do file access dot write because we are writing to the file. Later when we're loading, we'll be using file access dot read. We'll create a new variable, JSON string. Yes, we're using JSON. This will get JSON dot stringify our save function. As we're returning the dictionary, so we will just have the dictionary here. So let's go save game dot store line JSON underscore string. And that's it. That's how we save it. So if we run this just once, we have to call it function ready. Call save game. If we run this, it has saved. If we open up our folder, if we go Windows R, add data, and we go to save system store, go to save game, you can see here, we have all of our data. All right, now to load data, we can do function load game. Here, we will quickly check if the file exists because, if we call this before we save, it won't exist and it will throw an error. So if not file access dot file underscore exists, and we'll get our file path name. If this is not true, we will return. All right, now we will create a new variable called save game. This will get file access dot open, the same file path. But now we will do file access dot read. And here we will do while save underscore game dot get position. We'll get save game is less than save game dot get underscore length. Variable JSON string. This will get save game dot get underscore line. So we are reading this line by line. Variable JSON. We'll get JSON dot new. We will parse the result. Parse underscore result. We will set this to JSON dot parse. We will get the JSON string we created. And now we will store that data into a node data. This will get JSON dot get data. All right, so this is reading it line by line, and we'll print out that finalized data. So node, press play, it'll save. Now if we run load game and press play, you can see it will print out our saved data. Anyways, guys, thank you for watching. If you have any questions or comments, please leave them down below. Don't forget to like and subscribe. Thank you. Hello everyone, welcome to the part 2 of the save and load system.
Okay, hold up. Okay, so what I want to know is
hello everyone.
save data resource Godot 4. Save files in Godot, custom resource to tutorial, but which Godot? All right, let's see. All right, what is this? Is this? Resource node. Godot 4, my guide on how resources work. How to make your own. Custom resources are OP indeed. Excellent write-up. Okay, let's look. Custom resources are OP in Godot 4. Using custom resources has been a massive game changer for me. When Godot 4 was being released, what could be a better time to share a guide? Recently, a friend of mine who also used a resource in Godot is an object that represents data and properties. A resource in this data can be saved and loaded from files, and Godot's documentation refers to them as data containers. When you import images, sounds, fonts, they become resources. Yeah. Why custom resources classes are useful. Is he talking about this for save data? When should you use them? Player save data. Okay. Well, then let's look in the documentation. What's the node called again? They're called like resource preloader. Documentation. Resource preloader. Resource preloader. This node is used to preload sub-resources inside a scene. So when a scene is loaded, all the resources are ready to use and can be retrieved from the preloader. You can add resources using the Resource Preloader tab when the node is selected. GD script has a simplified GD script.preload built in. Can be used for most situations, leaving the use of Resource Preloader for more advanced situations. Oh, okay. Come on. Right, that's for preloading scenes. So is this a Godot 3 only thing? resource. Okay. Yeah, I don't think you can use this in Godot 4. Let's keep looking for information. How to save and load games data easily in Godot 4. So just click this.
Having a way to save data is important to any game. No matter if you want to remember the player's health, what level the player's on, or something more complex like saving the player's inventory, which I will be making a video on really soon. But this is the sample that we will be creating in this tutorial. We can change these variables here, which are just simple variables with buttons that we can change the number of. We can save this data, and when we change up these numbers, we can load that data back, or we can save this data. But if we load the data back, we're gonna go back to what we had. This even works when we close out of the game. So let's say that we want 8, 6, and 5, or 4, or 5. It doesn't really matter. So 6, 8, and 5. We save this data, we'll load it, and you see it changes, or it keeps it the same. But if we change up the numbers a little bit, we can load the data, and it's going to keep it at this. But if we close out of the game, and then we close out of GODOT completely, then we go back down here and open up this project again, then hit
GODOT.
F6 to replay the game. You're going to see that we can change these numbers to whatever we want.
I wish it
But
was
if we click load data,
GODOT.
we're going to have the numbers that we saved a moment ago. So this is going to store this data outside of GODOT. I will explain to you step by step how and why everything works. So you will be able to go and create your own save and load system in your own game from the knowledge you learned from this video. If you could subscribe and drop a like on this video so YouTube can push this to more aspiring game developers, then it would mean the world to me. But let's get started. Right now we have a pretty simple game. We have a save data function and a load data function that do absolutely nothing. We have different numbers that change different variables on the screen, and we can't really do anything because nothing works, right? In our script, our save button does nothing, and our load button also does nothing. We have 3 variables at the very top, and we have 3 rich text labels that are updated constantly through the process function based on what those variables are. Those variables are changed by our 2 buttons, a minus button and a plus button, that just changes the variable very simply. Same with the variable 2 and same with variable 3. In this tutorial, we're gonna go over how to create the save button and how to create the load button.
Yeah, for our purposes, we don't need much more complication than that, honestly. That's pretty much all we need.
And this load button to change data.
Just like level and your coins, I guess.
And work data and save data and load data. So to get started with saving data in our GODOT projects, we need to create a save path. We'll go to our script and we'll say var save underscore path equals whatever you want to save it toward. I'll save it in the user. I'll name this save file variable with .save at the end. Now with the save path, we will create a new file that will save this data outside of GODOT in the project's data folder. So we'll create a new function called save, and we need to open the file on our save path and change variables inside. So to do that, we'll say var file equals file access.open save path file access.write. This is going to allow us to change variables inside of the file. Then we need to select the data that we want to save by doing file.store var and whatever variable name you have for every single variable you want to store in this file. So we'll do variable 1, variable 2, and variable 3. This allows us to create a new file that will store outside of GODOT whatever variables we tell it to. Then we will be able to access and change these variables as things change in the game, which I'm about to explain in a little more depth toward the end of this video. So now we need a way to load the data we save. So we will create a new function and check if the file with the save path name exists. So we'll name this function load data if file access.file underscore exists save path, and if that comes back true, then we're going to want to open the file named save path. We do this by saying var file equals file access.open save path file access.read. Now we want to handpick the variables we saved earlier out of the file we just accessed. So in our script, we'll change variable 1 to equal file.getVar variable 1. We'll change variable 2 to equal file.getVar variable 2, and we'll do the same thing for 3. But when we check to see if the file exists and it comes back false, or if it comes back false, we need a way to show that no data has been saved in that file. So we'll do this by putting an else statement to the original if statement, and we'll print no data saved, and we'll reset all the variables to 0. Now we are able to access the file with our saved data and load it into its corresponding variable names that will update the rich text labels in our process function. Now we need to run the save function and load data function when their respective buttons have been pressed. So when our save button's pressed, we'll call the save function, and when our load button's pressed, we'll call the load data function. Now theoretically, we should be able to run this game and everything will work. So let's play our game. We'll change the variables a little bit around, and we will, save the data, change them up a little bit, and we will load the data, and we can see that everything works. Now, obviously, if we close out of GODOT, we reopen it, we can see that if we load the data, everything works just fine. So that is how you create a save system in GODOT. Now let's say you want to use this as a basic stat system to hold data, right? You want to have the players out at 8, you want to have the in-game time at 5, and you want to have the selected inventory slot at 3. Well, you would have to know that. You would save this data, and the next time you come into the game and you load it up, you'll see that you'll know the player slot is at 8, you'll know that the inventory or the game time is at 5, and you know that the inventory slot is number 3. How would you use this to store different inventory slots? We'll say 2 variables are going to be assigned to each inventory slot. This is going to be the ID of the item in the slot. So let's say the ID of 3 equals an apple. That's the ID, the object ID. And then how many apples are we going to have in the slot? We'll say there is 8 apples in the slot. And what slot number is the apple in? Well, this is probably going to be known because variable 1 is going to be slot 1.
So what I'm getting from this is that there's definitely more than one way to do this. So great. I kind of liked the idea of the resource thing, but It doesn't really seem like that's a thing in Godot 4. Like, I can't tell, but
and then slot 1 item number, right? And then we'll save the data. Next time we come into the game and it loads up and we click the load button, we'll remember, okay, slot 1 has 3 and 8. So then we'll know, okay, we need to have apples and we have 8 apples in that inventory slot. I'm currently working on an inventory system right now that I will release very, very soon. So stay tuned for that. But thank you guys so much for watching. I hope this video helped. And if you have any questions at all, then please let me know in the comments down below. Subscribe if you haven't already, and I'll see you next time. Stay safe and have a wonderful, wonderful rest of your day.
I recently made 2 videos about saving the player's progression with resources in Godot. One of you pointed out how it's unsafe to use resources if players download save games from the web, for example, to unlock content without having to grind. Godot's resources can bundle code, and that code could be malicious. We say that resources support arbitrary code execution. Some of you care very much, so I decided to take some time to look into it. And it turns out you can combine resources and a safe format like JSON to get security without losing flexibility. In this video, we'll first look at how resources can execute arbitrary code and all the features you should avoid to keep your
okay, but he's still using Godot 3, and since we're using Godot 4, we're not going to go through that video. It still seems, I don't know, maybe there's still like a security issue. I don't know, but it doesn't look like they're using this method anymore. So we'll you know what? We're gonna just do it the simplest way possible. Because all I want to do right now is save the level. All right. Hang on, I'll be right back.
Having a way to save data is important to
See if he's got anything else. This guy's not a bad creator.
Hello and welcome to episode 8 of the How to Make an RPG Game in GODOT 4. And today we're going to be adding these health bars to our enemy and our player.
Maybe we'll do this whole tutorial sometime. I think I would actually like to do that. Like, I don't like doing too many tutorials, but sometimes like doing one to up your skill can really like take away a lot of friction when you're making your own game or when you're making your own project, right? Like, for example, I've resisted learning anything about Bootstrap that I couldn't just look up and paste in. And I did one tutorial on stream the other day. And now, like, I'm no expert, but I can at least understand what it is and how to make things look the way I want them to in, you know, at least reasonably so. And it's helped a ton. It has helped a ton. Sometimes a straightforward tutorial where they just tell you what to do, but you understand what you're doing because they're explaining it well. It can help a lot. So this is our website now. I think it looks a lot better than it did the other day. It's obviously still a work in progress, but see, I got everything in a flex box. Everything's responsive in a cool way. It can fit on a phone. It can fit on a giant screen. The brand is there. I think it looks pretty good. Our live stream is here. Down at the bottom, you can see. Oh, I didn't even notice it. That's so cool. Actually, it's a live stream. So yeah. Um,
Hey, so particles in GODOT are pretty cool and easy to use. And in this video, well, I wanted to go over everything there is to know about the particle 2D node, from an explanation of important things to know, and then at this timestamp, we will create different in-game examples like fire, rain, and explosions. But before we get started, if you could subscribe and drop a like on this video to have YouTube push this tutorial to more aspiring game devs, then it would mean the
okay. Yes, we're going to do this. Because we were working on my, if you weren't here for it, we were working on the particles earlier, and I was winging it a little, but let's see if we can learn something about them that'll help us use particles rather than animations for our fireballs. Because we were using an animation, but I'd really love to figure out how to make this look correct. I mean, I think it looks pretty good, but it doesn't explode or anything. It also doesn't shoot the right way. So if I turn this way and shoot, see it's shooting the wrong way. But it does look pretty cool there. I think it looks awesome. So let's see what he has to say.
absolute world to me. But how does the particle node work? So first of all, there are two different nodes, the GPU particle 2D and the CPU particle 2D. And most of the time you're going to want to use the CPU particle 2D, unless you're wanting to spawn tons of particles, because in that case, then you want to use the GPU particle 2D since it uses the GPU, and in turn will help the game in performance. If you're using the CPU particle 2D, then you may see a dip in performance when spawning a high number of particles because it won't be using the GPU. So particles can be used for so many different things, from explosions, fire, rain, and so much other stuff. And I want to take the time here to go over how to create those different effects step by step and explain the inspector and all the options the particle node has, so you're able to go and create anything that you need with a particle node. So let's get started by creating an explosion effect. And to do this, we're going to create a 2D scene, and we can just name this scene the explosion because that's what it's going to be. That's the effect that we're going to create, and we're going to go here, and then we're going to add a particle 2D. So a CPU particle 2D is what we're going to be using, and you can see that we're already spawning particles. But for an explosion, well, there's going to be a couple things that we're going to have to change, like the gravity, right? So if we come to the gravity and we click it to 0, you're going to see it's going to stop falling completely. If we set it to a negative number, well, you're going to see it's going to go up. If we set it to a number, it's going to go down, right? And we want it at 0 for an explosion because we want it to go in all the directions. We don't want it to tell in a certain direction, you know, a certain amount. So we won't do that. And then we're going to go into time. And for an explosion, there's this explosiveness little number here. And this obviously, as of now, doesn't do anything. But if we turn our gravity up, let's say we have our gravity at 100, you're going to see that when we change explosiveness, how it works, right? So that's going to release them at different times, but this is going to release them all at once. So that has 8 particles, and each one of these particles, you see that's 8 particles falling, and that's what we want for an explosion, right? But we're going to want them to all go at the same time and go different ways, but we're going to want them to be different sizes, right? So to do that, we can come down here to the scale, and we can change the scale, and you can see this is going to be scaled 2. They're all going to be scaled up to 2, or if we go to 4, you're going to see it's going to choose a random scale, but we're going to actually have to change this explosiveness so we can see it. You can see that they're all different sizes, right?
Right.
All of the pieces are different sizes.
Pretty much know this already when I was making it.
If we want them to fade and get smaller, right? Because now they're all just going to disappear and they're going to be solid the whole time. If we want them to like get smaller as they go down, well, because like an explosion, you're going to want it to get smaller. You don't want it to stay the same size as the entire explosion. We can come down here to our scale, and we're going to have a scale amount rank here. And if we click a new curve, we can click on it. And if we right click at number 1, well, it's going to stay the exact same.
I think I did that too. Hang on. Scale amount curve, yeah. I thought I did something to change the direction. Set direction. Direction. Particles. Direction. Negative 100. Negative 100. This should be 100. Now. Okay, now it works.
Spawns, whenever it spawns in, it's going to be equal to times 1 of its scale. So the number's going to stay the same. But if we come down here, then it's going to be equal to times, right? It's going to fade. And it's going to go down here, and it's going to be equal to whatever this is. So maybe this is like times 2.5 of the fade, right? So it's going to take this number, and it's going to go to 2.5 times whatever its original scale is. And it's going to get smaller as it goes down. As you can see, if we go all the way up, well, it's going to stay the same. If we come down, well, it's going to fade into absolutely nothing. But we'll go somewhere around this area just like that. And it doesn't really look good now, but it will look good here in a second if we fix up some stuff. So let's change let's go back up to the top. Let's turn on our explosiveness up to a lot, you know, the biggest that it can do. And then in our direction, I want to go here. Where's our direction? I want to go here, and I want to move the spread up. And then we're going to go into our initial velocity. This is the one that matters the most. This is what's going to actually be the entire movement. If we set this to, we'll say 50, you're going to see that it has a little explosion. But they are all going to go the exact same distance. If we set the max of it, let's set the max, let's set the minimum velocity to 50, and then let's set the maximum velocity to 100. And you're going to see now some of them are going to go farther than others, right? And that's what we're going to want for a little explosion. And it looks like an explosion, but there's not many particles. So if we go up here to the top, we can set the particles to about 60. And you're going to see how that looks. And you got to see that these go forever. And they look very, very, like, this is like a firework. This is a huge explosion. So to fix this, we can go to our lifetime. We can cut that in half. And you're going to see it's a quicker explosion. It's quicker, and it's more dense, and it's right there. And that looks like a pretty good explosion. Maybe we can up the particle amount, but you don't really need to up the particle amount because I think it's pretty good at 60. Not 6, but 60. And then now so now if we go and we add a script to our explosion, we can add a script here. And this script is going to basically just turn on and off our explosion. So all this is going to do is if we click enter, it's going to turn the explosion on. So we can say input.is action just press UI accept, and we can say something like the CPU particle 2D dot emitting is going to equal to true. We can save the scene, and we can save the script. We can go to our particle 2D here, and we're going to go to our time one more time. We're going to turn this to one shot because, as you can see, if it's on one shot, well, we're going to have to turn emitting on for it to explode. Then emitting's going to go off automatically on its own. If it's not on one shot and emitting's on, then it's going to just keep looping and over and over. So if we turn one shot on just like this, and then we go and we play the explosion scene, every time we click enter, you're going to see it's going to be way up here because it's going to be kind of small. So to fix that, camera 2D, set the camera 2D zoom to 5, and if we play and we click enter, you're going to see that is a explosion, and that looks pretty good for an explosion. So that's how you create an explosion. But now let's go and let's create a fire effect. Okay, so the fire effect is going to be a little bit more complex, and to create this, we're going to go up here, we're going to create a new scene, we're going to make a 2D scene, and we can just name this fire. So fire is going to be much more complex than the last one. We're still going to use a CPU particle system here. And on the CPU particle system, we're going to have a bunch of different stuff. So first of all, our gravity, we're going to want it to go up, right? It's fire, so gravity, if we set it to like -600, you're going to see now the gravity is going to go up, and our particles are going to also go up at the same time. Now, you can kind of see it emits from exactly one point. So if we go to our emission shape, we can change our emission shape to a rectangle. If it does that, then let's say we expand it. You can kind of see that it's going to expand all around. That's how we're going to create rain. But from a rectangle, we do not want a rectangle. We're going to go make a sphere. And a sphere is going to have a sphere. So if we change the radius here, and we can change the radius maybe like 10, you can kind of see that it's all going to come out from around this area down here. And well, for this, it's going to be a pretty big amount of particles. So maybe like 2,000. So this is going to be a lot of particles, right? And you can kind of see how that looks. That kind of looks like what the prototype kind of looks like, just a little bit. We can go down here, we can set our lifetime to maybe 0.5, so it's more dense and it doesn't go up as high because we don't want it to go up that high. And then we're going to have some other stuff. If we want it to come inwards like this, we can have it push inwards so it looks like it's all going up towards one point, and that would be radical. Excel down here. So if we turn this up, we can say maybe the minimum is -40, and maybe the max is -40, or 50 and 40, right? So -50 and -40.
Okay, that's good to know. So radial acceleration affects the like pointedness of it. Yeah, I kind of like that. That brings it in tighter. Actually, that looks kind of cool. Right? That looks kind of cool. Even though it's not exactly supposed to happen. Watch, when I fire the fireball, he spits a little fire out of his mouth before the fireball comes. Right? It's actually kind of cool. Eat fire. Da, 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 da. I definitely prefer this to the PNG. Blah. Oh, oh no, I died. Well, that's what I get. Blah, blah, blah. Blah, blah, blah. Hmm. Maybe we don't need these right now.
Differential here. You're gonna see how it goes up just like this. But what makes fire fire is, first of all, the scale. We want it to shrink as it goes up, so we can go fix that real quick. We can come down here to the scale, but then we're gonna change the color, and the color is going to be kind of complex, right? Because we're gonna have a gradient, and it's gonna fade into different colors. But the scale, we can say it can either be from 0.5 or it can be to, I don't know, maybe I guess 2. So it looks more dense, right? They're bigger particles, and they are, or they can be smaller particles. So they can be bigger or they can be smaller. We'll leave this at 0.5. I think that's fine. And then we're gonna do the same thing that we did on the explosion. We're gonna create one of these ranks, and we're gonna come down to where it fades. We don't want it to fade as much as the other one, maybe like 0.4 around here. And you can kind of see that looks like fire. The only thing that we are missing is the color, right? So if we come down here, we go to color and we change the color rant to new gradient. Well,
Okay. Took me a while to figure out that gradient thing too. I was like, why is it only black and white? It's not color at all. Anyway, as I was saying, know what the fuck I was saying. What the fuck was I saying? Oh, I wanted to look at the scale. Like full at the front, small at the back. Or it could just be like that. That would work too. Looks good. I gotta say that. It looks like a fireball. Let's see what he has to say about color. Maybe we can make the color a little better.
We can click on this and we can change up all these colors. You can kind of see how this looks. Now that doesn't look too good, but we can say the first color here is going to be black. We want this to maybe be some sort of red. And how would we make a nice looking red for a fire? Maybe we'll stick with this, right? So maybe we'll go with this. And then we can add a new point here. And this point is going to be a little bit of a change. This point is going to be more towards the orange side, right? A red-orange color, just like this. Maybe more orange. Yeah, maybe something like this, right? And then we're going to add another point. This point is going to be more yellow-orange. So if we make sure we have full orange, we can come more onto the yellow side, like this, right? That's gonna be more of a yellowish orange. Then we can come down here and we can make this color here completely transparent, just like this. So it's gonna fade away at it's gonna have a better flame. Then we can change this also to transparent because we don't really need that one. I didn't know that was even there. We would have just moved it forward a little bit. But you can kind of see how this looks. And the higher you want the smoke, the more you move this transparent backwards, and the higher the smoke will go. So maybe right there, maybe that looks good, right? And that kind of
Yeah, that's what I want. I want that too. So some transparency. I'm gonna add a transparent gradient color. Just Anyways, I'm sorry. I forgot I was on stream there for a second. I'm just trying to figure out interpolation, linear, cubic, linear. Maybe rotation. No. Reset that. Okay. I don't know. I don't like that. Why does it explode orange in the middle? I don't really understand why it does that.
Kind of looks like fire. Maybe we have to change up the red a little bit to make it a little bit more orangish off the start, so it's not as big of a change. Or maybe we can change this one up more towards yellow, something like this, right? That's gonna be fire. Obviously, you can play around with this. You can change it up to however you want it. Maybe we can make this more orange, something like this, and that's going to be fire. That's fire. That looks good. Now, real quick, I want to create a toggle. So we can come up here. Well, first of all, I guess we can add a camera 2D, and the camera 2D we can put into 5. And we can go here and we can add a script, and this script is going to be basically the exact same. We'll just say if input.is action just pressed UI accept, and then we'll create a quick toggle, and this toggle will be CPU particles dot emitting equals not that of CPU particles dot emitting, right? And we can save the scene, save the script, and then if we come back to the 2D scene, you're gonna come all the way up to the top. We don't want it on one shot and emitting. It can be emitting to start. That's fine. If we click play, you kind of see it looks more like a fire, right? That's how we would create a fire. We can turn it on, turn it off, turn it on, turn it off, just like fire should be able to turn on and off. And that looks good. That looks very
Just
nice,
like
right? So
fire
that's
should
gonna
be
fine.
able to be turned
Now,
on and
we're
off.
gonna go and create the very last effect, which is going to be rain.
Just
right?
say that,
As we're
sure.
going through this tutorial, hopefully you've seen how all the settings work and how all the settings
Yeah.
work. The best way to learn about the
Yeah, you can totally
is to
do
go
that.
through all of the inspector and just play around with it and make your own things with it. So let's go create the rain real quick, and that's gonna be the last effect for this video. Okay, so now quickly to create.
All right, we don't need the rain. Man, I don't. Don't save. What happened to we don't save? Does it go back to where we had it before? Because it was pretty good where it was. I think I messed with it too much. Okay. Now what we want to do is we'll rename this Fireball Particles. And then I don't know, I guess we'll just duplicate it. Does this work? Still? Set direction. Still not work. Yeah, renaming it messed something up. Okay. All right, we'll rename this. Explosion. All right. And time, probably be less. Oh. Sphere. Gravity. 0. Explosiveness. We'll do that later. Direction. What do I do again? There we go. Okay. Sorry, guys. I keep forgetting that I'm on stream. Anyways, that kind of seems like an explosion. Color RAM, new gradient. I'll rename this. If I can find the freaking rename button. Maybe not. Okay. Fireball. At on ready bar explosion particles equals CPU particles 2D. Explosion particles dot emitting I don't know, equals true. Fireball particles dot emitting equals false. Emitting is a Boolean. Set emitting. Okay, set emitting. Sorry, set emitting. Set emitting false. I can't even tell if it went off. Uh, yeah, I don't think it did it.
Rain will go up to the top 2D scene, and we're of CPU particles dot emitting, right? And we can save the scene, save the script, and then if we come back to the 2D scene, be way up here because it's going to be kind of small. So to fix that one shot, well, we're going to have to test UI accept, and we can say something like the CPU particle 2D dot emitting is equal to true.
Okay, dot emitting equals true. That was right the first time. I still don't think it worked. Oh, wait. What is the enemy? Oh, the enemy isn't. Sorry. I got that wrong. No! I don't think it worked. All right, I'll be right back. Let me put on a video real quick.
We can save the scene and we can save the script. We can
Let's
go to our
play
particle
this.
2D here. An explanation of important things to know, and then at this timestamp we will create different in-game examples like fire, rain, and explosions. But before we get started, if you could subscribe and drop a like on this video to have YouTube push this tutorial to more aspiring game devs, then it would mean the absolute world to me.
Subscribe to DevWorm. He's the video we're
watching. There are two
watching.
different nodes, the GPU particle 2D and the CPU particle 2D. And most of the time you're going to want to use the CPU particle 2D. Unless you're wanting to spawn tons of particles, because in that case then you want to use the GPU particle 2D since it uses the GPU. And in turn will help the game in performance. If you're using the CPU particle 2D, then you may see a dip in performance when spawning a high number of particles because it won't be using the GPU. So particles can be used for so many different things, from explosions, fire, rain, and so much other stuff. And I want to take the time here to go over how to create those different effects step by step and explain the inspector and all the options the particle node has, so you're able to go and create anything that you need with a particle node. So let's get started by creating an explosion effect. And to do this, we're going to create a 2D scene, and we can just name this scene the explosion because that's what it's going to be. That's the effect that we're going to create. And then we're going to go here, and then we're going to add a particle 2D. So a CPU particle 2D is what we're going to be using, and you can see that we're already spawning particles. But for an explosion, well, there's going to be a couple things that we're gonna have to change, like the gravity, right? So if we come to the gravity and we click it to 0, you're gonna see it's gonna stop falling completely. If we set it to a negative number, well, you're gonna see it's gonna go up. If we set it to a number, it's gonna go down, right? And we want to add 0 for an explosion because we want it to go in all the directions. We don't want it to tell in a certain direction, you know, a certain amount. So we won't do that. And then we're gonna go into time. And for an explosion, there's this explosiveness little number here, and this obviously as of now doesn't do anything. But if we turn our gravity up, let's say we have our gravity at 100, you're gonna see that when we change explosiveness, how it works, right? So that's gonna release them at different times, but this is gonna release them all at once. So that has 8 particles, and each one of these particles, you see that's 8 particles falling, and that's what we want for an explosion, right? But we're gonna want them to all go at the same time and go different ways, but we're gonna want them to be different sizes, right? So to do that, we can come down here to the scale, and we can change scale, and you can see this is gonna be scaled 2. They're all gonna be scaled up to 2, or if we go to 4, you're gonna see it's gonna choose a random scale, but we're gonna actually have to change this explosiveness so we can see it. You can see that they're all different sizes, right? All of the pieces are different sizes. We're gonna turn explosiveness off for now, but you can see they're all different sizes. And if we want them to fade and get smaller, right? Because now they're all just gonna disappear and they're gonna be solid the whole time. If we want them to like get smaller as they go down, well, because like an explosion, you're gonna want it to get smaller. You don't want it to stay the same size the entire explosion. We can come down here to our scale, and we're gonna have a scale amount rank here. And if we click a new curve, we can click on it. And if we right click at number 1, well, it's going to stay the exact same because whenever.
Okay. Ah. Well, that's probably why then. Let's just start over. Okay, so explosion.
It spawns, whenever it spawns in, it's going to be equal to times 1 of its scale. So the number is going to stay the same. But if we come down here, then it's going to be equal to times, right? It's going to fade, and it's going to node. So let's get started by creating an explosion effect. And to do this, we're going to create a 2D scene, and we can just name this scene the explosion because that's what it's going to be. That's the effect that we're going to create. And then we're going to go here, and then we're going to add a particle 2D. So a CPU particle 2D is what we're going to be using. And you can see that we're already spawning particles. But for an explosion, well, there's going to be a couple things that we're going to have to change, like the gravity, right? So if we come to the gravity and we click it to 0, you're going to see it's going to stop falling completely. If we set it to a negative number, well, you're going to see it's going to go up. If we set it to a number, it's going to go down, right? And we want to add 0 for an explosion because we want it to go in all the directions. We don't want it to tell in a certain direction, you know, a certain amount. So we won't do that. And then we're going to go into time. And for an explosion, there's this explosiveness little number here, and this obviously as of now doesn't do anything. But if we turn our gravity up, let's say we have our gravity at 100, you're going to see that when we change explosiveness, how it works, right? So that's going to release them at different times, but this is going to release them all at once. So that has 8 particles, and each one of these particles, you see that's 8 particles falling, and that's what we want for an explosion, right? But we're going to want them to all go at the same time and go different ways, but we're going to want them to be different sizes, right? So to do that, we can come down here to the scale, and we can change scale. And you can see this is going to be scaled 2. They're all going to be scaled up to 2. Or if we go to 4, you're going to see it's going to choose a random scale, but we're going to actually have to change this explosiveness so we can see it. You can see that they're all different sizes, right? All of the pieces are different sizes. We're going to turn explosiveness off for now, but you can see they're all different sizes. And if we want them to fade and get smaller, right? Because now they're all just going to disappear and they're going to be solid the whole time. If we want them to like get smaller as they go down, well, because like an explosion, you're going to want it to get smaller. You don't want it to stay the same size the entire explosion. We can come down here to our scale, and we're going to have a scale amount rank here. And if we click a new curve, we can click on it. And if we right click at number 1, well, it's going to stay the exact same because whenever it spawns in, it's going to be equal to times 1 of its scale. So the number is going to stay the same. But if we come down here, then it's going to be equal to times, right? It's going to fade, and it's going to go down here, and it's going to be equal to whatever this is. So maybe this is like times 2.5 of the fade, right? So it's going to take this number and it's going to go to 2.5 times whatever its original scale is. And it's going to get smaller as it goes down. As you can see, if we go all the way up, well, it's going to stay the same. If we come down, well, it's going to fade into absolutely nothing.
Right.
We'll go somewhere around this area just like that. And it doesn't really look good now, but it will look good here in a second if we fix up some stuff. So let's change gravity back to 0. Let's go back up to the top. Let's turn on our explosiveness up to a lot, you know, the biggest that it can do. And then in our direction, I want to go here. Where's our direction? I want to go here and I want to move this spread up. And then we're going to go into our initial velocity. This is the one that matters the most. This is what's going to actually be the back up to the top. Let's turn on our explosiveness up to a lot, you know, the biggest that it can do. And then in our direction, I want to go here. Where's our direction? I want to go here and I want to move this spread up. And then we're going to go into our initial velocity. This is the one that matters the most. This is what's going to actually be the entire movement. If we set this to, we'll say 50, you're going to see that it has a little explosion. But they are going to go the exact same distance. If we set the max of it, let's set the minimum velocity to 50, and then let's set the maximum velocity to 100. And you're going to see now some of them are going to go farther than others, right? And that's what we're going to want for a little explosion. And it looks like an explosion, but there's not many particles. So if we go up here to the top, we can set the particles to about 60. And you're going to see how that looks. And you can see that these go forever. And they look very, very, like, this is like a firework. This is a huge explosion. So to fix this, we can go to our lifetime. We can cut that in half. You're going to see it's a quicker explosion. It's quicker and it's more dense, and it's right there. And that looks like a pretty good explosion. Maybe we can up the particle amount. But you don't really need to up the particle amount because I think it looks pretty good.
All right, let's see. Explosion. No, it still didn't work. Oh. Please, 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 please. Yay, it worked. Okay, let's try again. It should do it when it times out now also. Blah. Blah. Okay, so one, we can definitely reduce the particle size. Gravity. We can increase this. Better. Ugh. Pretty good, right? Maybe we could just do the overall scale. Just increase it to 2. Yeah, pretty good. I need a Yancy. I'm wondering if maybe fewer would be better. Would it be 500? Yeah, and just the size of them. Emission shape. B. I guess point is fine. Direction, also fine. Gravity, good. Velocity. What's this do? I mean, that looks pretty good. There. That's probably a little better. What is speed? Speed scale. A little faster. Faster. Maybe like 1 point. Oop, not 4. 1.5. Not 105. Damn it. 1.5. This is pretty good, right? It's just like a firework, which is kind of what you want. Okay. I'll be back in a minute, I guess. here. God, I just... Okay. Sorry. Here, watch Thor.
And I'm old enough to know when my shit don't matter, right? It don't matter. None of this matters. Fleeting essence. There we go. Where is the vibrant? There it is. Yay, it all looks good. It all looks good. It all looks good. I feel ways about stuff and it makes me feel old. Good. Feel ways about stuff. But don't waste your time. You're not getting more of it. Alright. Rune Carver is finished. I have the Pillager, Outpost Destroyed, Holiday, and Dungeons to go. Ugh. I think the only holiday one we have to do is Easter. What is this? Theoretically, you're now Old Man Yells at Cloud with Twitch being on the cloud. But it's nice to see more old people on Twitch streaming. How dare you? How dare you? How dare you? You're not wrong. But how dare you? Chat's rude. Chat is rude. I don't think I actually changed the Egg of the Mothman now that I think about it. I think Egg of the Mothman is exactly the same as it was before. Because it doesn't drop. That's a quest item, they don't drop. That way, this will be easy. You making a Minecraft mod? I'm actually working on Block Game, which is our Minecraft MMO right now. I had like a lot of work this last week for Block Game. It's not normal that I have so much work for it, but it needed to be done because I updated the shit out of the game with so many new players. And I'm trying to get us into a spot where we can just go make Neath, which is the next dungeon. And I'm excited for that. I have it all designed out on paper. So that's kind of what I'm looking forward to right now, is Neath. Save. Okay, now for the annoying bits. Because we have a couple of new things in here that are gonna suck to build. We've got Pillager Outpost. And I've got two of these. Outpost and Outpost Top. Outpost is the easy one, because that doesn't have a unique or special item. So that's always exactly the same. Outpost Top has a special quest item that I have to go pull out of the game. Do you like chili dogs? Hell yeah, I like chili dogs. You kidding me? Wait a minute. Where's the chest? Experience chest in this. Oh, I got rid of it. Yeah, these don't have experience in them. Okay, I remember now. Yeah, get rid of the experience book in this. You know what I like in chili dogs, though? I don't like a hot dog. Hot dogs are gross. You know what I like? I like bratwurst. Give me a chili dog, but make it bratwurst. Yeah. I love the shit out of that. I love the shit out of that, dude. Chili brat? I'm in. Even brats with, like, sauerkraut on it? Oh, I'm so in. I'm so in. Yeah. Yeah. Currywurst? Super in. Super in. God, I love currywurst. I'm so into that. Damn right. Yeah, dude. Stop making me hungry? No, I refuse. Because I'm hungry. You love Polish sausage? Yeah. I also like Russian sausages. Like Russian wedding sausage. Super good, man. Really good shit. There's a Russian market not too far from me. And I go to the Russian market like maybe once a month. And everyone there speaks Russian, so I can't communicate with anyone. I just point at things. I go to them like... And they're like, how many? And I was like... That many. And they're like, okay. Because none of them speak English. But I go there and I get it all... Oh, God, I love it. So good. It's so good, dude. Yeah, it's 100% a Russian market. It's all Russian products, and they have the best meat deli. Oh my God, it's so good. The meat deli is so good, dude. Russian meats are awesome. Yeah, hand signals. It's all hand signals. Gestures, dude. Yeah, they're great. How about a good Reuben? I love Reuben sandwiches. That's my favorite sandwich. Oh, dude, Reuben sandwich is my favorite. And you know what upsets me? You know what upsets me? There's nowhere around here to get a good Reuben. Because they don't do the bread right. You gotta have, no, not just on rye. It's gotta be the swirly rye, dude. The proper rye. It's got, oh, a Reuben needs that kind of, Reuben's about the bread, dude. It's gotta have the proper bread. Let me go find it. Here, 1 second. I'm gonna pause this. Where is this? No. Shouldn't be on. Where did it go? Where did it go? It's on the other window. There we go. Found it. Reuben sandwich. There's a kind of bread that it has to have, and it's swirly, and it's delicious, and it's a rye swirl bread. It's partially rye. Oh God, that's a good Reuben right there. See that shit? You see that shit? That marbled rye? Oh, that's the bread, dude. If it doesn't have bread like that, it ain't shit. This is a proper Reuben, dude. It's got the cheese, it's got the crown, it's got the meat, it's got the Reuben. It's got the Reuben bread. You need it all. You need it, God, oh. Arby's ain't shit. No, dude. Arby's is like the only place you can get like a Reuben at a fast food place. And it's like, look, I'm going to be honest with you. Every couple of months, I go to Arby's and I eat the poor man's Reuben. And it's not because I want to eat Arby's. It's because I want a Reuben. And to be real with you, the Arby's Reuben is like, it's like a distant memory of what a Reuben should be. It's so upsetting. It's not good. It's not a good Reuben. But it's the best Reuben you can get right then. I know, it's like 3 a.m., nowhere is open. I can't make the Reuben at home because I just don't have the ingredients. You wait until like 6 a.m. when they open, or whatever the hell it is. You go to the Arby's. I'm not lying. I've gotten the Arby's Reuben. It's not good. It's okay. It's okay. It's a sad boy Reuben. It's okay. Yeah, it's not great. Yeah. It's 8 here. We'll see it at noon. Dude, it's not a good Reuben. I wish it's good enough. It's good enough. I agree with that. Yeah. But dude, I love a Reuben sandwich. Reuben sandwich is my favorite sandwich. Onigiri mustard stream win. Mustard stream? We just talk about mustard for an hour? Oh god, dude. German mustard wins. And German mustard, and then like lightly below that, like Polish and Russian mustards. Yeah. German mustard and then Polish Russian. Dijon, everything else. You've never tried real mustard, have you? You've never had like good German mustard, have you? So I got ruined for mustard recently. Sophie, who's one of our moderators, she's German, and she sent me mustard from Germany, and it ruined me. I no longer like any other mustards. Yeah, that's the one. I don't know how to pronounce that. It looks like Bautzner. Bautzner? I don't know how to pronounce that shit. I'm American. We can barely speak our own language. But like, dude, the mustard is so good. It's so good. It's ridiculous. I cannot handle it. She sent me like 4 different mustards, and one of them was that one. And I just can't handle it. I can't handle it. In the United States, we have this thing called French's mustard, right? Thank you for the rating party, too. What's up? We're having a good day. So we have a horrible mustard in the United States called French's. And I'm going to show you what this looks like. Now, you may think that this is the plastic bottle, but the mustard looks exactly like this anyway. American flavor in a bottle. So this is ass. This is ass. Now, Bautzner looks like this, but tastes really good. This tastes like ass. And if you don't agree with me, you've never had German mustard. This is what someone looked at German mustard and was like, I can match that color. They had no concept of what it tasted like. They just tried to match the color. That's it. That's all that it is. Dude, I hate American mustard. It's so bad. It's so bad. So there's a couple different mustards that I have. Actually, I have one right near me. One sec. I have it right in my mini fridge. Hell yeah. So there's a French mustard that I have that comes in a clay pot. You see this? Get that shit on Amazon, dude. And it lasts forever. It's a clay pot of mustard. It's a clay pot of mustard. It's a French mustard, and it's really goddamn good. And then there's a German mustard that I got from Sophie that I don't know how to get more of, and I want that. And then the last one is this Russian mustard that has a screaming old woman on it. So I'm going to look up old woman Russian mustard. And it's the first result. There it is. It's the first result. Because everyone knows the old woman screaming mustard. Look at this. Look at this mustard. This mustard burns your face off. The moment it touches the back of your throat, it ascends into your sinuses and removes them from you. It is wonderful. It is the most ridiculous, painful experience in your life. The hell was that? Something just fell near me. I don't know what it was. But anyway, she's not screaming. You're screaming. She's going, whoo. And the reason she's making that face is because you make that face when you're eating this mustard. It's true. Anyway, I'm going to go put this mustard back in the fridge. Oh, man. God, I love the mustard. You have no idea. I love mustard. How do I search for that at work? Wait, how do I search that work? What, dude? What's the German one? Sophie sent it to me. There was a bunch of different ones. But one of them is Bautzner? Bautzner? Senf? Mustard. Let me look this up. Okay, this is gonna look weird, right? But it came in this little, like, plastic container. One of them did? Yeah. Let me find this. One of them came in like a Mario glass, which we kept. It was nice. This is God tier mustard. It doesn't look like it. It doesn't look like it. But it is. It's God tier mustard. Germany doesn't screw around with mustard. They don't screw around at all. It's amazing. Why is it so good? Why is it so good? That Russian mustard is actually made in Canada? Don't give a shit. It's amazing. It's sold at the Russian store and it's incredible. The ones that I get are all written in Russian all over it. If it's made in Canada, who cares? You also have a spicy version of this? I like spicy mustard. That's nice. You know what I like to do? It's kind of funny. Whoever has heard of tahini? It looks like it's spelled like this. One sec. Tahini? You ever seen that? Tahini? So tahini is really good. It's a seasoning combination, right? Flavor combination. There are peanuts near me. There's a market near me that sells tahini peanuts. So what I do is I take them home and I put them into the food processor and I make tahini peanut butter. Now that is some delicious shit. That is really good. Yeah, I make a big old jar of tahini peanut butter and it lasts forever because it's like heavily salted from the tahini. God, it's good. It's so good. I love that shit. Anyway, hi Bezos. He's excited about it and the ferrets have crashed. Let's go fix that. Yeah, tahini peanut butter is... Oh. God. I love it so much. I need to make more of it. I ate it all. Gold brick. Need a raw carrot now. And then a raw potato. And then a raw beetroot. Okay, those are finished. Now we have the big problem. The big problem is the curious parcel. What are you doing? This music's cute. Where is it from? It's all from our game Heartbound, which you can find on Steam. Steam-arino! Heartbound, or the exclamation point Heartbound command. Yeah. It's all made in-house, man. Why did the demo cost money? It doesn't, you goblin. It is free. It is a free demo. And the ads are over. Next.
Cascanoiders with 500 bits said Microsoft Defender keeps marking my PowerShell scripts as malware.
Yes.
Any PowerShell script is malware. Good luck making any automation. Also divide by -0.
You divide by -0. I think we tried that at one point on stream. When it was broken with the -0 bug. I think we did actually try that. And I don't think it did anything weird. Okay, so now we need another one of these.
I apologize for my absence. I have children, if I didn't mention it before, 2 of them, and they're very, very small. So they need a lot of help. Fortunately, I work from home, and this is easy to put on pause because there's nobody watching anyway. So, anyways, what were we doing? We were doing the particle thing. Yeah. We finally figured it out. But also, I was thinking about it while I was upstairs, and I was like, we did not need to do this. Like, this was silly. I just want to keep making it look better, though. Oh, you definitely need it, though, for sure. All right, let's go with the color. I think that's okay. You can always make it different. Because he made it. It should be one shot. Particles still need to be smaller. Yeah, the particles need to be smaller. All right. Cool. I think I need to leave it there, guys. At least for now. Thank you for coming. I'm going to keep working on this, and I'll give you an update soon. But I gotta go. This is Tony with Red Cyber Dragon. Have a great day, everyone.